Hi, my name is Mr. Kangas, and today we're going to be taking a look at Chapter 7, Section 1. And in this section, we're actually going to take some time to discuss how you would identify a function just by looking at the graph it creates. Because remember, a function is a special group of ordered pairs. So if you have multiple ordered pairs and you graph them, it will create almost like a picture on a graph, and based on that picture we can identify whether or not it's a function. So, some things just to review about functions that we've established so far. Functions, what's special about them, what's special about these groups of ordered pairs is that there is a pattern or relationship between x and y, between the x and y coordinates. So I'm going to write that in there. Between x and y. There's a special relationship or pattern between x and y. Now, you will not always be able to see that pattern. Sometimes it will be a simple pattern and you'll be able to see it when you look at the group of ordered pairs. Sometimes you won't. One other thing that's special about a function is because there is a pattern or relationship between x and y, there has to be an equation for that function. In math, you can take any pattern or relationship and make an equation out of it. Okay? That's something that's very special about it, because the way relationships and patterns work is when you input something, you always output something specific. The output's not random. Okay? So if I input 2 into my equation, I'm always going to get this for an answer. I'm never going to get anything else. So you can make an equation based on that. A quick example, 2x equals y. If I input 5 in for x, I do 2 times 5 and I'll get 10 for y. So that means every time I input 5 into this equation for x, I should always get 10 for y. That shouldn't change. Okay? The third thing we know about functions is that you cannot input a number twice and get 2 different answers. I cannot input 5 into that equation I had up earlier and get 2 different answers. Whenever I input 5, I should always get the same answer. If you see an input repeat in a function and it gets you 2 different answers, you do not have a function. So for example, I'm going to erase this, so if you need to write this down, pause it. Okay. If I had a function like this, okay, when I input 3 I got 5. When I input 5 I got 7. When I input 7 I got 10. I input 7 again and I got a different answer, I got 9. This is not a function. I cannot input a number twice like I did and get 2 different answers. So this is the primary or the best way to identify if a group of ordered pairs is a function if you have a table in front of you with all the ordered pairs. All you need to do is look. Do I have any numbers that repeat? In this case I had 2 7s. The 7s repeated. They repeated and gave me different answers. So this is not a function. I don't have to graph it. I don't have to know what the equation is or what the equation could be. Because in this case there isn't an equation because it's not a function. Okay? This is just a relation. A relation is just a random group of ordered pairs. Okay? So it's kind of a quick recap from the last video. And another quick recap here. When you have the x and y columns, you could also call this the input or the domain. You call this the output or the range. Okay. Another way to explain functions that works well for some people is when you describe it as a machine. Okay, I'm going to input I'm going to input something into my machine. And then it's going to give me an output. So when I input something in my machine has some sort of function. It's got some sort of responsibility. What does my machine do? In this case, my machine doubles whatever I put in. And that's my output. So if I input 5, it doubles it, and I output 10. That's what this equation represents right here. That's what this function represents. Okay, the function of this machine is to double the input and give me an output that's twice as big. So if I had my ordered pairs, I would input 7, the output should be 14. I should never input 7 and get an output other than 14 or my machine's broken. My machine is not functioning. If I input 7 and get an answer other than 14 into this machine, my machine is not functioning, therefore my machine is not a function. So if I have another 7 on my list and I get 13, that's not a function. Okay? So I said I was going to talk to you about how to identify a function just by looking at its graph. So I'm going to put a coordinate grid over here. We're going to start talking about that right now. Okay, remember this is the origin, y-axis, x-axis. So we're going to use some small functions or small groups of, special groups of ordered pairs. Okay, if I have 2, 3, 3, 4, and 4, 5. Okay, this is a function. You can see my domain does not repeat. Okay, they're all different numbers. So that's technically a function right now. So if I graph it, over 2, up 3, over 3, up 4, over 4, up 5, you're going to see that this function has created a straight line. Now, since I'm doing it freehand, it's not going to look perfectly straight, but those 3 points that I put up here created a straight line. Or in other words, it created a linear equation. Because remember, each function has an equation that goes with it that represents the relationship between x and y. So for example, going back to this one, this equation represents the function of this group of ordered pair. Okay? This equation represents the relationship between the x-coordinate and the y-coordinate. It's telling you that the x-coordinate, when doubled, gets you the y-coordinate. Or it's telling you that y is half of the x-coordinate, or y is twice as big as the x-coordinate. Okay? So the equation tells you that relationship between x and y. Also, if you have a function, then you have to have an equation. There is an equation. Now, the patterns that get you a straight line, or the functions that get you straight lines, are considered linear equations because they're functions that, when graphed, get you a straight line. So, one type of function is a straight line. And that type of function is known as a linear equation, because it will always get you a straight line. Now, if you recall correctly, when you're looking at the table of ordered pair, the domain cannot repeat. So, and if you remember, the domain is the same as the input and is the same as the x coordinate. So there's actually a really easy way to identify if your function is in fact actually a function. For example, if I see something like this, this is not a function, and there are two reasons I know this. One of those reasons is that it does not pass the vertical line test. So if I took a pencil, a ruler, marker, book, something that can form a vertical line for me, and remember, vertical is up and down, and I place it vertically on my graph, and I move it across my graph, what you're going to notice is that my marker is currently intersecting two different points on this black line here, which means that this line does not represent a function. Okay? Right here and here, for example, my marker intersected both of those points at the same time. And what that means is that your domain repeats and gets you two different answers. And I'll show you. If you take a look at this top point, the x-coordinate is 1. The y-coordinate is 2. If you take a look at the bottom coordinate, the bottom point, the x-coordinate is also 1. So in other words, the domain has repeated. I have two 1s. But the range in this point is 1 instead of 2. So that means I input 1, got 2, input 1 again, and got 1 for my answer. That doesn't make sense. There's not an equation in existence that you can make where you would input 1 twice and get two different answers. There's no pattern, there's no relationship where you would input 1 and get two different answers. And if you actually go further down, there's another point right here that has an x-coordinate of 1. We went over 1, but we went down 3. So I've got 1 appearing 3 times in my domain with 3 different answers. So that's how you know that this is not a function, because it did not pass what's called the vertical line test. Okay? That's a very easy way to always identify if the graph represents a function. Another way, because you don't always have lines like that, you don't always have solid lines. Sometimes you just have random points scattered all about. The vertical line test still works for those as well. At any point, I'm intersecting 2 points at the same time, it's not a function. In this case, that never happened. If you take a look, I went through this point, no other points. No other points. No other points. None here. None here. And none here. Okay? So the vertical line test is a great way to identify if you have a function. Another way to identify if you have a function, if you aren't comfortable with the vertical line test, is just to understand the different types of lines that make functions. So straight lines we discussed. Straight lines are functions. The only straight line that you'll find that is not a function is a vertical line. Because if you take a look at a vertical line, no matter what 2 points you pick, they all have the same x-coordinate. In this case, that x-coordinate is 2. In every single one of these points on that vertical line, I'm going over 2, and I'm going up or down a certain amount. Every point on this line has a domain or an input of 2, but a different output. So the only straight line that is not a function is a vertical line. Again, you can test that with a vertical line test. Right there, my eraser's on the line vertically, and it's touching multiple points. Okay. The other types of lines you will see, though, that do represent functions are curves and waves. Okay? You'll never have 2 points intersecting on a wave or on a curve or on a straight line. Okay? Now, why do curves, waves, and straight lines represent functions? What's so special about these? And just as a heads up, the only kind of functions we're going to be working with in this chapter are the first ones, the straight lines, the linear equations. We won't get to curves and waves this year. Okay? There's a chance we might, but most likely not. Never has happened before. Okay? So what is special about straight lines, curves, and waves? What makes them functions? Or how else can you identify that they're a function? Is because they're always moving forward. Okay? They never stand still. Okay? They never stop. And they never stand still. They always move forward. Okay? So if you're looking at something, a wave is always moving forward. A curve, always moving forward. It never stops and it never turns around. Okay? Always moving forward, never stops, never turns around. That's how you can tell just by looking at the graph that this is a function. The other way you can tell is if you're looking at it and you see that it's a straight line, a curve, or a wave. Okay? If you see this, okay, that is not a function. It's turning around right here, and then it starts going forward again. It was moving forward, then it started moving backwards and turning around. So that makes it not a function because it needs to always be moving forward. You can never turn backwards, you can never turn around. You can never stop. This is a function. It's always moving forward. It never stopped, it never turned around. Okay, even right here, it's still moving forward. It's not turning around, it's not stopping, it's still moving forward. However, this is not a function. It stopped right here. Okay, it's not moving forward. It's moving up, but it's not moving forward. Okay, so this one is not always moving forward, so it's not a function. So that's really about the gist of things. Why are functions important? because functions aren't necessarily just describing a relationship between an x-coordinate and a y-coordinate. It's important to understand that those x-coordinates and y-coordinates represent real things. Those functions are representing relationships between real things. X and y represent actual things. So it does have everyday practical applications or uses. A lot of the technology that we use today in cell phones and video games and TV and the internet and everything, there's a lot of functions going on there. It's saying if this happens, then you get this. Or even something simple like, you know, the X might represent Johnny's cookies and the Y might represent Missy's cookies. So if Johnny gets 4 cookies, then Missy gets 8 cookies, because Missy gets twice as many as John. So you can actually make formulas and algebraic patterns out of simple stuff like that. But again, to identify a function by looking at a graph, you're looking for a straight line, a curve, or a wave. And if you have trouble remembering that, try to remember that the picture it represents needs to always be moving forward. It can't stop, and it can't turn around. But that's it for Chapter 7, Section 1. In the next section, we'll actually be delving into linear equations themselves. So that'll be Chapter 7, Section 2.